In this module, we're diving into supervised machine learning, a way of using past data to make smart predictions about the future. Think of it like this: if you know how customers behaved in the past, you can guess who might leave soon. If you know which products had issues before, you might predict which new ones could be faulty. Or maybe you want to estimate how long a delivery will take based on past orders. That's the kind of thing we're talking about, using past examples to make better decisions going forward. We'll look at two main types of predictions: classification and regression. Classification is about predicting categories, like deciding whether an email is spam or not. Regression is about predicting numbers, like figuring out the price of a house based on its features. In both cases, we train the computer with examples where we already know the correct answer, so it can learn to make predictions for new cases. One method you might already know is linear regression, where you fit a straight line through some data points. The goal is to find the best fitting line, meaning the right slope and starting point, and then use that line to make predictions. We'll also explore two types of learning methods: parametric and non-parametric. Parametric methods use a fixed formula and adjust certain numbers, called parameters, to fit the data. Linear regression is one of these. Non-parametric methods don't rely on a formula. Instead, they look directly at the data and find patterns, like the k-nearest neighbors method, where you make a prediction by comparing something new to the most similar past examples. Another key idea you'll learn about is the bias-variance trade-off. In simple terms, a model that's too simple might miss important patterns. This is called underfitting, while a model that's too complex might learn the training data too well, even its noise and quirks, and won't work well on new data. This is overfitting. A good model finds a balance in between. When it comes to classification, we'll introduce the confusion matrix, a handy tool that shows how many predictions were right or wrong. From this, we can calculate things like accuracy, precision, and recall, which help us understand how well a model is performing. For more complex classification problems, we'll talk about methods like cross-entropy and KL divergence, which are also used in training neural networks, something you'll see more of in a later module. Finally, we'll cover resampling methods. These are techniques to better estimate how well a model will perform on new, unseen data, which is super important when you want your predictions to hold up in the real world. All in all, supervised learning methods like classification and regression are at the heart of predictive analytics. This module will help you understand how they work and how to judge whether they're doing a good job, skills that are essential for real-world data projects.